A few days ago, one of my monitors suddenly decided to start being a little bit sluggish, starting up in the morning. It would turn on and then just turn off again, and turn on and turn off again, on and off, on and off. If I try turning it on, you see the blue light on this one. Zoom in. There we go. See if we can actually see it. If I turn off my light, it tries to power up and fails miserably. That should be on solid blue, and I should have a nice LG logo on the screen. But instead, all I get is flashing on, off, on, off. But about 10-15 minutes after powering it up, it suddenly starts working again. I'll just look over to that monitor expecting to see nothing, and it'll have my desktop on it. So, time for a repair job. Now, my best guess with this is that there is bulging capacitors in the power supply. So let's take a look. Now, the first job is to get into this. There are no screws at all. So I reckon that it's going to be a case of levering off this front surround and hoping that I don't snap something. They do tend to make these very much one way, clip them together and then never come apart again. So, how are we going to manage this? Try. Can I lever this up? It's, oh yeah, that. Oh yes. Oh, ow. It wants to come. Starting to think about it. That is not going to be easy. I think a spudger is needed. Can I get this into the edge? Oh yeah, it's starting to come. Oh, this is not an easy screen to get into. Oh, I think I'm gonna have to possibly do this off screen, off camera, and ow. Well, they really did not want me to get into this, but get into it I did. It really is a one-way operation putting these together. I've even snapped or bent the edge of the casing there. It's not critical, thankfully, but wow, that was not easy to get into. My fingers now are, almost cut, but not quite, thankfully. Okay. So theoretically the back now should just lift away. There we go. Okay, what do we have here? Backlight connections, front panel connection and the LCD connection, and that's it now. Looks like there's nothing at all holding the back piece on here. So let's disconnect the backlight. Yeah, nothing at all. Oh. Looks like we've got aluminium tape holding down the ribbon cable here. Let's pop that out. So this should just lift up and away. There we go. Okay, we can dispose of the screen portion now. And here is our main controller system. Wow. I don't think I've seen a controller board quite that small before. That is tiny. Let's pop that out and have a look at it. Got the VGA connector, has got screws there. Where's my 5mm should do it? Yep. there is our controller board. Now that is by far the smallest controller board that I have ever laid eyes on. That is tiny. Let's have a look. What is there on here then? Very little, it has to be said. We have got, let's get something to point with. There's my pointy gone, there it is. Main controller chip. In this case it is, where are my glasses? The TSUM 1PFR-LF A5ME6C, so C66E. No idea. I don't even recognise the logo on it. A couple of voltage regulators, 3.3 volt there, that'll be a 1.8 probably. Yep. AS 1117L-18, yep. Probably an EEPROM there, or a flash chip of some form. Capacitors really are what I'm most interested in looking at. Is there anything bulging? No. They all look good to me. There's no obvious signs of bulging in those capacitors. Everything looks good on there. No dry joints. So I think we can put that to one side and move on to the power supply board. Now, this is most likely where there is a problem. So let's pop this out. I'm always nervous working on a power supply board when it has recently been powered on, because the main filter capacitor may well have a very high voltage in it. So to help with that, I have made a special capacitor discharging lead. It is simply 2 crocodile clips, or alligator clips if you live in the Everglades, with a 1 megohm resistor in the middle of it. It's inside the heat shielding here. Okay, so I clip onto one side of the big capacitor, bring this along to the other and connect it on to that pin there. I wait for a moment or two, and that will make sure that the capacitor has discharged safely. Because if you're going to get a shock off this, that's the capacitor that's going to do it, and it will hurt. I used to just short out the capacitor with a screwdriver, up until the day when there was a spark so big it actually fractured and blew apart one of the legs. So I now use the wire first with the resistor in it, and then just double check with the screwdriver just to make sure. Okay, I would count that as safe. Now then, yes, immediately I can see that one of these capacitors is bulging. If we can bring this a little closer and get some light shining on it, get it into shot. There we go. This one here, as you can see, has a definite bulge to it compared to the ones next to it. That is obviously a failed component, and that is most likely the source of my problems. So let's just have a quick look at the rest of the board. It's not a bad board, this. Main power input, some filtering, a fuse, the bridge rectifier, smoothing capacitor, little controller chip down in there, the transformer, output filtering and smoothing. This half of the board over here is all the inverter for the CCFL backlights. So you've got another transformer, another controller chip. It looks a bit sparse, but that's because everything else is on the other side. As with most power supplies, they've opted for a single-sided SRBP board rather than a more expensive FR4. So it's all the surface mount components are on the reverse. But there's not much there, just a few resistors, capacitors, the odd diode, and one controller chip there. That's about all, really. Ow. So yeah, I'm going to replace that capacitor. I might as well do the other two while I'm at it. Are they the same? In fact, what make are they? Suscon. S-U-S-C-O-N. Suscon. Never heard of them. Yes, they're all 470 microfarad, 25 volts, and 105 degrees centigrade temperature rating. I might increase that. So yes, I guess it's now time to order myself some more capacitors and replace them and see if that solves my problem. Right, I'll see you tomorrow when I've got some capacitors. Okay then, welcome back. I have capacitors. So let's get to repairing. I opted to get genuine Panasonic. They're still only 105 centigrade, but these are Panasonics, or at least I ordered Panasonic. It doesn't actually say Panasonic on them, but I trust Farnell. They don't normally stitch me up. Okay, so these should be a direct drop-in replacement for these. Slightly lower profile, but other than that, identical. Okay, so first job is I need to get my soldering iron warmed up. That's going to take a few moments. And replace these three capacitors. Now, where are those on here? That's C501, C808 and C802. There's C501, C808 and C... where are we? That's C808, that's C812, was it? No, C802. There's C802, goes that way, does it? No, it is 812. 802 is that little ceramic one down in there. My mistake. So 812, which is this one here. Okay. So we've got there, there and there. That should be easy enough. See if this has warmed up enough. The way that I deal with these capacitors is grab them from beneath, heat up the pin and just pull it to one side, and the pin should ease through. There we go, one removed. Easy job. Okay, next one. The beauty of single-sided boards like this is they are so easy to desolder. You haven't got any through-hole plating to grab onto everything. Two removed, and the third one. There we go. Now a bit of solder wick to clean up the holes. Let's get this into shot, shall we? Very focused, it's hard to tell. There. Okay. C501. C808. and C812. A lot of solder on this one. There we go. Okay. That was easily done. So 1, 2, 3 new capacitors. The black marking on the board here indicates the negative side of the capacitor, so line the negative up to the black portion. The black marking is a convention, so you can pretty much rely on it, although it does pay to check when you're doing your desoldering that it is actually that way around. I did have a quick glance before to make sure. Spread the legs out to hold it in place. Okay, now we can get to soldering. It'd be nice if this does fix it all. It's only a small monitor, this one. Well, I say small. Small by today's standards. It's only a 17-inch. But it's a nice monitor, though. And it would be a shame for it to be dead. And a quick, easy fix is always good. And that was quick and easy. Let's just hope it was a fix. Trim off the excess legs. That doesn't look too good, that one there. There's a lot of track, exposed track around it for extra current handling. Okay, that looks good to me. They're all nicely seated. Just going to check over the rest of the board, make sure there's nothing untoward with the rest of it. There's no obvious dry joints. A few of them do look a bit crusty, but it's getting on a bit, this monitor now. It was actually given to me. I'm not sure exactly how old it is. Is there a manufacturing date on here? Manufactured February 2009. So it's 11 years old now. 11 and a half years old, so it's not bad lifetime for a monitor. Be nice to keep it working for a few more years yet. Yeah, everything looks okay. You can expect the solder to go a bit dull and rough over time. Starts forming what are called tin whiskers, where the surface of the solder just starts to grow outwards in thin whiskers as the metal migrates. Yep. Okay, I think I'll call that a fix, so long as it actually works. So now, time to put everything back together again. Should be an awful lot easier than taking it apart, believe me. Okay, a couple of screws for this. There's one in that corner and one up here. Notice there's a screw hole here that didn't have a screw in it at all. Let's zoom us out a bit. There we go. I don't know why it didn't have a screw in, it just hadn't had one in from the factory. And there's a screw hole here with nowhere to screw it to. Instead there's just a little spring clip. I guess there's clips in the side here, so that screw's not really needed, so they've saved themselves about 1/100 of a penny by not having that screw in there. But you sell 100 units, that's a penny they've saved. Skin flints. Okay. Let's pop the controller board back in. One screw here. Two posts. Okay, now the screen. Oh. Again, it surprised me that there's nothing at all holding this in place. It's free to wave around as it sees fit. But I guess once the casing is all in place, it sort of holds it there, but not ideal really. But it's lasted 11 years, so I guess it works. Put the back on it. Flip it over. Oh, it's come a bit awry there. Okay, that's in. Front bezel. Plug the cable into the socket in the front. There we go. Now I'm not going to clip this together just yet, because I don't want to test it, find that it doesn't work, and then have to open it all up again. So let's get some power. Fingers crossed. Look at that. I don't know about you, but I just saw an LG logo briefly. And yes, check signal cable. Let's turn my filter so you can see it and focus. There we go. Turn it off. Turn it on again. Come on, turn it on again. There we go. LG. It's fixed. That has cheered me up no end. Right, time to put it back together again and get it up and running. And there we have it, one fully working monitor. That's just saved me buying another one, although I probably wouldn't replace it because it's just sat in the corner of the room. It's useful for putting debug logs on when I'm programming or playing a video, whatever, watching telly on. So I would miss it, but it's not a critical one. Still, thank you for watching, and I hope that you learned a little bit from this.